Welcome back, everyone. Today, we are going to discuss the topic of collision resolution techniques in hashing. First, let's see what is collision in hashing. We generally insert elements in hash table using some hash key functions like modular division method. So, collision occurs in the hash table when more than one element is to be placed at the same key value. First, let us understand what is the process of hash table. So in hash table we store elements, and in hash table elements are called as records and the indexes are called as keys. So collision occurs when, first of all, modular division method returns a value. It's like we have to calculate the value is the key value at which we have to place the record. So collision occurs when more than one value is to be placed at the same key value. We cannot place more than one in the same key value. So this phenomena is called as collision. So to overcome collision, we use some techniques called as collision resolution techniques like separate chaining, open addressing linear probing, open addressing quadratic probing, and double hashing. Today we are going to discuss about separate chaining and open addressing linear probing. Let us see what is separate chaining. In separate chaining, we use the concept of pointers for storing multiple elements at a single key. Let us understand this by using an example. The example in records, they gave 11, 23, 55, and so on up to 86, and they also gave hash table size is 10. And first of all, if anyone don't know modular division method, we use h of k. Like h of k is the key value. You go to r mod hts, like r percentile hts. Here hts is the hash table size, r is the record. So when we try to create the hash table, it will be like the following. Hash table, you can see the figure, it will be like this. And let us first see the h of k values here. First record is 11, so 11 percentage 10. 10 is the hash table size, it gave us 1. So we have to place 11 at 1 key value. Similarly, 23, we have to place at 3. 55, we have to place at 5. And next, when we come to 31, it again gave 1. So 31 will also be placed at 1. So here collision occurred. And similarly, when we follow 86 is placed at 6 comfortably. And but 33, when we do 33 percentile 10, it returns 3. So at 3 already 23 is there. So here also collision occurred. So to solve this using separate chaining, we have the following solution. In above hash table, as you can see, collision occurred at key values 1 and 3. So in order to solve this by separate chaining, we represent rectangles at 1 and 0, key value 1 and key value 0 as. In hash table will be same, but at 1 we represent it like this. Like 1 will point towards first element, that is 11, and 11 in 11 the first will be data, and next will point towards the another, like which element causes collision, we have to point towards that, like 31. And after 31 no element is there, so this slash is nothing but null. Similarly, at 3 also, first 23, it points toward 23, and from 23 it points toward 33. So this is how separate chaining works. But one drawback of separate chaining is we cannot access the elements directly. Like we have to use another searching technique to access the elements. Now let's see the second method, that is open addressing linear probing. We have two techniques in linear probing. The first one is, so let us take the previous example only. They gave us records and hash table size is 10. అండ్ ఫస్ట్ 11% 10 ఇచ్చిండు. ఇక్కడ 1 వచ్చింది కాబట్టి 1 ప్లేస్లో 11 పెట్టినాం. తర్వాత 31 ఉంది. 31 మనం 11 దగ్గర పెట్టలేము, ఎందుకంటే కొలిజన్ అక్కర్ అయింది కాబట్టి. సో ఈ ఫస్ట్ టెక్నిక్లో మనకి ఆర్మాడ్ హెచ్టిఎస్తో వచ్చేది జంప్స్ అన్నమాట. సో ఇక్కడ 31% 1 వచ్చింది కాబట్టి 11 దగ్గర పట్టాలి కాబట్టి 11 నుంచి 1 జంప్, దట్ ఈస్ 1 జంప్ అయితే 2. 2 దగ్గర 31 ప్లేస్ చేసినాం. తర్వాత ఈ 23 యాజ్ యూజువల్ ప్లేస్ చేసినాం, 55 యాజ్ యూజువల్ ప్లేస్ చేసినాం. ఆఫ్టర్వర్డ్స్ వెన్ ఇట్ కమ్స్ టు 33, ఇట్ గేవ్ ఎస్ 33% 10. సో 3 జంప్స్ ఫ్రమ్ its actual value, like 23, 1, 2, 3. So it gave us 6. So at 6 we place 33. But now we cannot place 86. So this is the main drawback of first technique of linear probing. So you can see the drawbacks. We cannot place every record, and key value most of the time doesn't respond to its record. So let's see the second technique of linear probing. In this, we won't jump, but instead we move the record to the next empty key value, like nearest empty node after the collided solution. వి ప్లేస్డ్ ఆల్ ఆఫ్ దెమ్ అండ్ ఎట్ ఎట్ 131 ఇక్కడ 31 ప్లేస్ చేయాలి, కానీ 31 ప్లేస్ ఇక్కడ ఫస్ట్ నెక్స్ట్ ఆల్రెడీ 11 ఉంది కాబట్టి 11 తర్వాత 2 ఖాళీగానే ఉంటుంది కాబట్టి 31 దీంట్లో ప్లేస్ చేసేసినాం కంఫర్టబుల్గా. సో సిమిలర్లీ 23 దగ్గర ప్లేస్ చేయాలి, కానీ అక్కడ ప్లేస్ లేదు కాబట్టి 33 దగ్గర ప్లేస్ చేసినాం కంఫర్టబుల్లీ. అండ్ 55 86 కొలిషన్ అక్కర్లేదు, నార్మల్గా ప్లేస్ చేసినాం. బట్ 90కి కూడా జీరోనే వస్తుంది కాబట్టి 70 దగ్గర ప్లేస్ చేయాల్సి వస్తుంది. బట్ 70 తర్వాత ఏది ఎంటీ లేదు, సో నియరెస్ట్ ఎంటీ ఈస్ ద సెవెంత్ వన్. సో 90 ఈస్ ప్లేస్ దట్ సెవెంత్ వన్. సో దిస్ ఈస్ ద సెకండ్ టెక్నిక్ ఇన్ collision resolution technique collision resolution technique, that is linear probing. I hope all of you understood this topic. Thank you.